Hi students, let's discuss factoring trinomials with a leading coefficient of 1. So in this section, you will be introduced to factoring trinomials. Now, what is a trinomial? So tri in trinomial is 3, so it's 3 terms. For example, if you have ax squared plus bx plus c, here's an example where you have 3 terms. And what is representing the leading coefficient here? What is representing the leading coefficient in ax squared plus bx plus c? Well, the a is representing the leading coefficient. So a here is taking the place of the leading coefficient. Now, if the leading coefficient is 1, or if a was 1, how would you write the form ax squared plus bx plus c? So again, if a equaled 1, how would you write that form? Well, we will write it as x squared plus bx plus c because a is understood. Factors of a trinomial will equal the product of 2 binomials. So you're going to see 2 parentheses, and this would be 2 binomials multiplied times each other. So these are the type of trinomials we're going to deal with in this lesson, where we are factoring the trinomial and the answer will result in 2 binomials. So let's begin. Let's begin factoring trinomials when the leading coefficient is 1. Again, our leading coefficient for x squared plus 8x plus 12 is considered to be a 1 here because it's understood. So a equals 1. B will equals what? So in this case we have the b here. So b here is 8. And what about c? C is 12 in this case. So first I wanted you to identify what were the numbers for A, B, and C. Because to factor this trinomial, we only need to find factors of C that sum up or add to B. So what is C again? C is 12. So I have a little T table that I use in my class. I draw a little T. Here's the T. And you see here where I say, I typed, place C here. So what we're going to do is put C here. I'm going to put the 12 here. And we're going to write out all the factors of 12. Now, what are factors? I'm saying give me 2 numbers that when you multiply it, you will get the product 12. And let's do this decently in order. So we have 1 and 12 because 1 times 12 is 12. We have 2 times 6. And we have 3 times 4. So we wrote the factors out for 12. Now what factors would add up to B? And what is B again for this particular problem? B is 8. So B is the coefficient of the middle term here. B is the coefficient of the middle term. Okay, so now notice also that this is in descending order. So it's best to write your trinomials or anything in math in that case. Usually we try to write it in descending order. It's not necessary, but most of the time it helps Sometimes it's not necessary at all, but most of the time it helps. Okay, so we're looking at our factors on the right here. We have 12. We have 1 times 12. If we add that up, wouldn't we get 13? So does that add to 8? No. What about 2 plus 6? What about 3 plus 4? So it looks like 2 times 6 will give us the 12 that we want. But at the same time, 2 plus 6 will give us the 8 that we want. And 2 times 6 will give us the 12 that we want. Again, 2 times 6 will give us the 12 that we want. 2 plus 6 will give us the 8 that we want. So those are the winning numbers, or that is the winning pair. So we choose 2 and 6. Now let's put out parentheses, and I have it already written here. We have 2 sets of parentheses because our answer will always be the product of 2 binomials. So first off, what times what will give you the x squared? That's usually easy because we're dealing with the easy case. It's just x times x. So anytime our leading coefficient is 1, it's going to be pretty simple. And that's why I call it the easy case here. Because when our leading coefficient is 1, it's not really anything to think about for the first term. You just split up x squared as x times x. Now, what do we put for the other numbers? We put the numbers that we found were the numbers that when you multiplied it, you get C, and when you add, you get B. So you had a positive 2 and a positive 6. Now, how can you check factors? Well, multiplication is the inverse of factoring. So we're going to check by multiplying. X times x is x squared. X times 6 is 6x. 2 times x is 2x. And 2 times 6 is 12. So when we put our like terms together, 6x plus 2x, we get 8x plus 12. This is exactly the same thing as the original polynomial or trinomial. Okay, here's a note that I want to go over before we move on to the next problem. Since multiplication is commutative, you could also write the previous answer as, well, since it was x plus 2 times x plus 6, you can also write it as x plus 6 times x plus 2. And you can check it to make sure, but you will get the same answer when you FOIL that out. Let's practice some more. Again, we have trinomials. There's no greatest common factor. So let's follow the steps of the easy case, which are first, identify what C is. C is 24. So we're going to put it here. We're going to write all the factors of 24. 1 and 24. 2 and 12. So say it with me. All the factors you think for 24 are what? 3 and 8. And you can use your calculator, right? So 24 divided by 3. 24 divided by 4. 4 and 6. Are there any other factors? Okay, now we need to decide what factors add up to give us negative 10. Now notice I did not initially put any signs here because we just want to focus on the positive factors, and then we decide whether or not we should use signs so that when we multiply our winning pair, we will get we would get the positive 24 that we want, but at the same time, when we add the pair, we get the negative 10. So, for example, if you add 1 and 24, you're going to get 25. You're going to get 2 plus 12, 14. You're going to get 3 plus 8. You're going to get 11. 4 plus 6 is a positive 10, but not a negative 10. So what can we do to manipulate the numbers so that we get a negative 10 when we add the numbers? So it's sort of like a game of chess, right? It's very strategic. You have to think about integer rules. So it's very important at this stage that you have learned integer rules, because this is really all about. Factoring trinomials is all about integer rules. So you would need a negative 4 and a negative 6 in order to multiply that to get a positive 24, but at the same time add to get a negative 10x. Again, multiplied is get the positive 24c, but add it to get the negative 10x. All right, so we're going to write our answer. Since this is an easy case, there are really no extra steps you have to take. We're going to get to the other case when the leading coefficient is not 1. But for now, really you can just draw your parentheses, put x times x, because x times x will give you this x squared. Always check that though, because it's not always x squared. And then you have the negative 4. So you have minus 4 minus 6 because you had negative 4 and negative 6. If you had positive, you would put a plus sign. And you always check this. X squared, that's negative 6x, negative 4x, and negative 4 times negative 6 is the positive 24 that we needed. So x squared minus 10x plus 24 checks out, because that's our original problem. Now, I'm not going to do that for each one of these, but I want you to always check. Okay, moving on to the next one, we have x squared plus 7x minus 30. So our C in this case is negative 30. So negative 30. So we see that C is negative, but I don't want you to focus on writing the negative factors. I want you to focus on writing positive factors of 30. So 1 and 30. 2 and 15. What's next? 3 and 10. What's next? 5 and 6. Now what will work? So that when we multiply the factors, we get negative 30. But at the same time, when we add the factors, we get positive 7. So pause the video. See if you can manipulate the signs of these factors so that it works in two directions. One direction would be multiply to get negative 30, and the other direction would be add to get positive 7. How can we satisfy both criteria at the same time? Well, hopefully you decided that if we make the 3 negative, this could work. Because negative 3 times 10 is negative 30, but negative 3 plus 10 is 7. So our answer is x minus 3 times x plus 10. Or again, let me just reiterate, x plus 10 times x minus 3 is the same thing. Just like in number 1, you could have written what? X minus 6 times x minus 4 instead. Moving on to the next problem, number 3, we have a negative 72 here. So negative 72 is our C. We're going to write factors of 72 out. For example, 1 is 72, 2 and 36. And again, get your calculators out. What is 72 divided by 3? What is 72 divided by 4, for example? I believe that's 4 times 18, 6 and 12, and 8 and 9. Again, pause the video. What will work? In this case, what is our B? What is our B? Please do not say N. What is our B? So again, when we refer to A, B, and C, what we're really referring to are the numbers in front of the variables, not the variables themselves. So when I ask you what is A, B, and C, you should not say variables, okay? You should say numbers. For example, numbers for those letters, because they represent coefficients and constants. Okay, so our B is -1. So what will work? What will work would be a -9 and a +8. So you will have N plus 8 times N minus 9, or N minus 9 times N plus 8. Let's move on to the next problem. What is C for number 4? If you said -168, you were correct. Now what I want you to do is pause the video, and I want you to write all the factors out for positive 168, and then turn around and come up with your winning pair by manipulating the signs of the pair. So hopefully you started out with 1 and 168, and then you worked your way to 2 and 84, for example. I'm not going to write all the factors, but hopefully you ended up somewhere with 12 and 14 at the bottom, right? And then you decided that we needed a -12 and a +14. So our answer is T minus 12 times T plus 14, or T plus 14 times T minus 12. Let's move on to the problem where I call it a challenge, because it looks a little different. I want you to notice that our degree here is 4 and not 2 like the other problems that we have worked out previously. But that's not a real issue, because we could split up x to the 4th. How? So if we had two binomials, right, and we multiply it together, we could still get x to the 4th if we split it up as x squared times x squared. We're still dealing with a trinomial because we have 1, 2, 3 terms here. So we're going to follow the steps that we were following before, because it is a trinomial and it's considered to have a leading coefficient of 1. So let's follow the steps we've been following in this video. So what is C? C here is -20. So -20. Let's only concern ourselves with the factors of +20 first. 1, 20, 2 and 10, 4 and 5. Now what will work? What will work is a -5 and a +4. So we have x squared plus 4 times x squared minus 5. Now always check to make sure that you have factored completely. And we have factored completely because these are not difference of squares. This is actually a sum of squares, the first one. And what do we know about a sum of squares? We know that a sum of squares is not factorable. And x squared minus 5 is not a difference of squares because 5 is not a square, a perfect square. So it is also not factorable. So this is actually the final answer. Moving on, don't ever lose sight of the very first step of factoring. And what is that very first step of factoring? Take out the GCF. So that's always the very first step of factoring. Now, for these problems, a polynomial is factored completely when it is written as a product of factors that cannot be factored any further. So, for number 1, factor completely. Notice it started with a negative. Now, here's a strategy. You could factor out the negative, right? So, if we take out negative first, right? Let's say negative 1 is the GCF. Let's just say that. We take that out, we get x squared. It will change all of our signs completely, right? And we get this. So all of our signs change. Notice that our signs switched inside of the parentheses. Next, what we're going to do is factor what's on the inside of the parentheses. So we have a negative on the outside. We know it's going to be x and x, but we want to find factors of negative 15 that add to negative 2. So we have 1 and 15, we have 3 and 5. What would work? Alright, if you said negative 5 would work and a positive 3, then you are right. So we have negative parenthesis x plus 3 times x minus 5. Since 3 plus a negative 5 is negative 2, which is what we get here. Because we already factor out a negative 1. Okay, so our final answer is this. Moving on to number 2, what should we do first? Again, you probably already forgot it, but don't worry, I got your back. The very first step you should always look for is take out the GCF. Alright, that's always the first step of factoring. So do we have a GCF here? We do. It's 3x. So when we take that out, we get x squared plus 5x plus 6. And what do we have inside here? A trinomial. So is that trinomial factorable? You bet it is. Normally it is. Sometimes it's not. But in this case, are there factors of 6 that add up to 5? Well, we have 1 and 6. Does that add up to 5? No. But 6 also has factors of 2 and 3 that actually work. So we have x plus 2, x plus 3. So the final answer is 3x times x plus 2 times x plus 3. Next, we have 3a squared plus 3a minus 18. 3 is in common with all 3 terms. So we take that 3 out first. Then we have a trinomial here. Now in this case, the c is negative 6. Again, please don't look at the original problem when you have taken out the GCF. Now we're looking at this row, not the original. Alright, so we're working with what's in purple here. So when you look at this, we have C here, the negative 6 here is our C. Again, we have 1 and 6 and 2 and 3. But we're looking for factors that multiply to give us negative 6, but at the same time add to give us B. Now what is B? 1. Alright, so it looks like what will work is what? Looks like a negative 2 times 3 will work. So our final answer is 3 times A minus 2 times A plus 3, since our winning pair was negative 2 and 3. Moving on, we have z to the 4 plus 2z cubed minus 80z squared. We can take out our GCF, which is z squared, leaving us with the other factor of z squared plus 2z minus 80. Now what is our C? Our C is negative 80. Now what factors of negative 80 would work? Because we have 1 and 80, of course, we have 2 and 40. We have 4 and 20. We have 5 and 16. We have 8 and 10, for example. What would work? It looks like a negative 8 and 10 will work. So z squared times z minus 8 times z plus 10 would work. Number 5 looks a little different because of this y squared at the end. But notice that we are dealing with a trinomial still. There are 3 terms still. And so we're going to treat it as an easy case trinomial. We're going to say 1 is our leading coefficient here. And we're going to say C is 20. All right. So 20, what are the factors of 20? 1 and 20, 2 and 10, 4 and 5. What would add up to, let's say B is 9. Okay. So what will work here? 4 and 5. So we have x times another x is not the issue. X times x would give you this x squared, so that's not the issue. But we have at the end that y squared, right? So all we have to do is simply put a y on the end of the 4 and 5, because when we multiply it, let's check it. We get x times x, x squared, x times 5y, 5xy, 4y times x, 4xy, 4y times 5y, 20y squared, which equals x squared. Then we have our like terms here. Our like terms add up to give us the 9xy that we want, that's in the middle, plus the 20y squared, so it checks out. So we know that the answer is x plus 4y times x plus 5y. Moving on to number 5, we have 4x squared, y minus 68, xy minus 72y. Again, we need to take out the GCF, which seems to be 4y, because notice that the y is in every term, so it's definitely in common. But x is not in every term, because notice we don't have an x in this term here, so we can't pull out an x. 4y times what is 4x squared y. Alright, so we got x squared minus 17x minus 18. And then this is a trinomial here, right? trinomial. So what we're going to do is factor that trinomial. Negative 18 is our C. 1 and 18, 2 and 9, 3 and 6, for example. What will work? It looks like negative 18 plus 1 will give us the negative 17 that we want. So 4y times x plus 1 times x minus 18 will work. So let me state the last note. Not all polynomials are factorable. For example, x squared plus 3x plus 5 is not factorable, and that's because if we try to find factors of c, which is 5, right, we have 1 and 5, which adds up to, right, 1 plus 5 is 6, not 3. So we can see that we cannot factor that type of trinomial. They call those trinomials prime because it's not factorable. Alright, so I want you to don't assume that all trinomials are factorable. The polynomials above were intentionally chosen for the purpose of practicing factoring. Okay, so that concludes the lesson on factoring trinomials when the leading coefficient is 1.